My name is Alexander Oman, and I'm a senior scientist at Bühlmann Laboratories, and I'm here today at the WORLDLAB 2024 in Dubai, presenting our poster and our work on recombinant calprotectin. Calprotectin is a very established biomarker in the diagnostics for inflammatory bowel diseases, and it is also an emerging biomarker for rheumatic diseases. And especially in the field of diagnostics for inflammatory bowel diseases, there's a big discrepancy between the quantitative results of different suppliers. So the goal of this project is to have a material that could be potentially used as a reference material for harmonizing all the quantitative results for different suppliers. Our recombinant calprotectin is a fusion protein where the two subunits similar to native calprotectin are linked with a linker, and this allows us to express it in bacterial cells at high quantitative, at high yields and at low cost, and high purity as well, as you can see here. The linker can be cut again afterwards to separate the two subunits, just like a native calprotectin. And what we've shown is to analyze the biological function and biophysical properties. And like native calprotectin, our recombinant calprotectin can tetramerize from its dimeric limit to the tetramer up on calcium addition. We have shown that here with size occlusion chromatography, where different mutations that are known to not tetramerize do not do it, but the other ones do tetramerize and shift to higher molecular weights. And in this experiment, we also compared the unfolding curves of our recombinant calprotectin and native calprotectin and get similar behavior when we add EDTA, so capture calcium, or we add calcium. In addition, the affinities for antibodies also are very comparable between native and recombinant calprotectin and show in general the trend that tetramers have a higher binding affinity. Importantly, for using it as a calibrator material, we get a linear relationship for the concentration of recombinant calprotectin for recognition by polyclonal and by monoclonal antibodies. And we've shown here in the commutability that if we measure with two different types of tests, an ELISA or polyclonal antibody test, if we measure patient samples or our recombinant calprotectin itself, we get a perfect agreement in the commutability. And lastly, when we calibrate an assay with native calprotectin or recombinant calprotectin and measure patient samples, in this case these were serum samples, we get an almost perfect agreement. The bacterial activity, which is known by native calprotectin to hamper bacterial growth, we see without calprotectin there is a increased bacterial growth, and in the presence of calprotectin the bacterial growth is reduced, which is even further reduced in the tetrameric shape, just like native calprotectin. And lastly, we did some stability studies and where we could extrapolate that the shelf life of the material would be between 3 to 7 years in refrigerated conditions, making it suitable to be used as a reference material and hopefully a tool to harmonize the different quantitative results that are currently present in the field for fecal calprotectin and maybe in the future also for serum calprotectin. Thank you very much.